nice problem because it's just, again, it's helping us, as you can see in calculus, we're combining a lot of different things that we learned in Algebra 2 and in pre-calculus. So we need to understand the question, and then I think answering it's going to be pretty easy. So at what point, so is the tangent to this graph horizontal? Well, we know that the tangent at any point right here, we can find out the slope of the tangent at any point on this function here by using our difference quotient. So that's going to give me the slope, and I'm trying to find out, well, where is it horizontal? Well, horizontal slope is equal to 0. So I want to find out at what point is the tangent to this function have a 0 slope. Well, first, I need to figure out, well, what is the equation to find the slope of the tangent? I'm going to rewrite my function in standard form, because I like the standard form better. Negative x squared minus 4x plus 3. And I know that if I find the limit as h approaches 0 of f of x plus h minus f of x divided by h, that is going to give me the slope of the tangent at any point x on this equation. So let's try it. I'm going to go, the limit as h approaches 0 of negative x plus h squared minus 4x plus h plus 3 minus, I'll put it in brackets so I don't lose a negative sign, negative x squared minus 4x plus 3, all divided by h. Limit as h approaches 0 of negative x squared plus 2xh plus h squared minus 4x minus 4h plus 3 plus, and carry my negative signs in, x squared plus 4x minus 3 all over h. So I have the limit as h approaches 0, negative x squared minus 2xh minus h squared minus 4x minus 4h plus 3 plus x squared plus 4x minus 3. All I did was distribute this negative sign into there so I could look at it more clearly. And now I'm going to start crossing stuff off. I have a negative x squared and a positive x squared. That goes away. I have a negative 4x and a positive 4x. That goes away. I think that's all that's going to go away here. So I have the limit as h approaches 0 of negative 2xh minus h squared minus 4h. Oh, the 3's go away. So I found something else there. So that is what I have so far, all over h. So I have the limit as h approaches 0 of h times negative 2x minus h minus 4 over h. And these h's are going to cancel out. So I have the limit as h approaches 0 of negative 2x minus h minus 4, and that equals negative 2x minus 4. So this is the equation of the slope of the tangent line at any point x on this function? Well, I know that I want to find out where is that slope equal to 0. Where is the line horizontal? So I go negative 2x minus 4. Where is that slope equal to 0? I get negative 2x equals 4. I get x equals negative 2. The original question asked me at what point is the tangent horizontal? Well, I've got my x value now of negative 2. So what I need to find is the y value. I need to find f of negative 2. So that equals, here's my function. Let's evaluate it for negative 2. So f of negative 2 equals negative 2 squared minus 4 times negative 2 plus 3. F of negative 2 equals negative 4 plus 8 plus 3. Is that right? I think so. Equals 4 plus 3 equals 7. So the point at which my tangent line is horizontal is the point negative 2, 7. Now I'm going to point something out to you that's going to help us going forward. You're really going to like this. First of all, I entered the equation into my calculator. Notice I did not put negative x in parentheses because the function says negative x squared. It's not asking for negative x squared. It's asking for negative x squared. So I put it in that way. And I'm going to go zoom 6. And looking at this at negative 2, let's just do something here. I'm going to go second calc. I want to find my maximum. And my left bound, I'm going to make, negative 3. And my right bound, I'm going to make 0. So I have a nice neighborhood there. And I'm going to go, I don't want to make a guess. And what do you know? My maximum here, well, I know it says negative 1.999, but that's the calculator. But my maximum is the point negative 2, 7. Well, let's look at this graph a little bit more. Sorry I can't draw on this better. Maybe I can do something here. Yes, this is a little bit better. I made the equation on the smartboard graph so I can write on it. You can see that the curves look about the same. And if I visualize the tangent line of this curve, like you can see right here, the tangent line is going to be very steep. And it's still going to be steep over here too. But as I get closer and closer to the maximum, my tangent line actually, that's a badly drawn line. Let's try it a little bit better. My tangent line is totally horizontal at the very tip there. And then it starts aiming downward. So one of the things we're going to learn going forward is that where you have a horizontal tangent line, that is either a minimum, a maximum, or a minimum of a graph. That's where the tangent line is going to be. Sorry, my smartboard isn't calibrated properly here. But that is where the tangent line is going to be horizontal. And so it happens right there. I can see that there's a maximum, and I can calculate what is my maximum. I'm going to go second, calc, maximum. My left bound, I'll make somewhere to the left of that maximum, negative 3. My right bound, I'll make to the right of that maximum, let's say 0. And I press enter, and it tells me there's my maximum right there at negative 2, 7. And that is where my tangent line is going to be horizontal.